Good evening, and welcome to the review for test number 3 in Math 0070 at Macomb South Campus. Ordinarily, I give 25 questions on this for this test, but things being the way they are and students generally doing fairly poorly in the past semesters, I decided to cut this down to 15 questions out of the original 25. There are some questions that all of you will be getting, but in a lot of cases where there were several questions of the same type, you're only getting about half of them. So that's how we cut down to 15 out of the following 25. Let's go ahead and get started. Okay, there are three systems of equations, and what I want you to do is classify them, not actually solve them, but simply tell me, do they have a solution? In which case they're consistent, and if they don't have a solution, then they're inconsistent. And then also, are they two different lines represented by the equations, in which case they are independent, and if they're the same line but one of the equations is multiple of the other, then they are dependent. So let's look at these three types of equations, systems of equations. You'll be getting 2 out of the 3 on your test. So if we look at the first one here, y is equal to x over 2 plus 3, and then x minus 2y is equal to 9. What we want to do is, if the lines have the same slope, then they are going to be parallel lines. If they have different constant terms, then they're going to be independent parallel lines, and that means that the system will be inconsistent because there's no solution. So they'll be inconsistent and independent. So if we take this second equation and we solve it in this case by substitution, we put x over 2 plus 3 in for y. Negative 2 times 2 gives us x minus x, and then negative 2 times 3 gives us a minus 6. This zeroes out. We get negative 6 is equal to 9, which is not a true statement. There's no value for x or y we can put in there that can make it a true statement. So that means that this is an inconsistent system. There is no set of values that will solve both equations. They have the same slope, it turns out. We would have seen that if we had just solved this one for y. We would have gotten y is equal to x over 2 minus 4.5 instead of a plus 3. So they're inconsistent because they're independent. They're two different lines that don't intersect. Okay, and those are the types of choices that you'll be offered. You know, consistent and independent, consistent and dependent, inconsistent and independent, inconsistent and dependent. Those are the 4 combinations of the 2 adjectives for the systems here. So in each case you're picking one of those 4. Okay, let's look at the second one here. Y is equal to 5x over 3 minus 5, and then our second equation is 5x minus 3y is equal to 15. Here, I just solved the second equation. I believe that's what I did, yeah. And we get that minus 3y is equal to bringing that 5x to the other side here to the right. It becomes minus 5x plus 15. Divide through by the negative 3, we get y is equal to 5x over 3 minus 5. And that's the same as our first equation. So that means these are coincident lines. One's just a multiple of the other, or actually just the same equation. So they are consistent because there are an infinite number of solutions, and dependent because they actually represent the same line. And then finally, our last of the three, y is equal to x minus 3, and then 4x plus 3y is equal to 12. And rather than just checking to see if they had the same slope or not, I went ahead and plugged in and worked this by substitution. Put in x minus 3 for the y here in the second equation, so we get 4x plus 3 times x minus 3, or 4x plus 3x minus 9. That gives us then 7x minus 9, or 7x adding 9 to both sides, we get 21. Divide through by 7 and we get x is equal to 3. So this is going to tell us then, if we plug this 3 in to our first equation, 3 minus 3 is 0. So that tells us that it intersects in a single point. So it's consistent, there is a solution, and the lines are independent because they intersect. They intersect in exactly one spot rather than an infinitely number of points. So those are the three types of systems of equations where I'm going to ask you to classify them. There's going to be another three where I ask you, to find the actual solution. This is just saying, is there a solution or not? Okay, hit the wrong button. All right, now I'm going to give you 4 word problems from the kinds that we've done on the in-class assignments. Hopefully, I have not mistakenly given you any of the actual problems that are on the test. But you're going to get 2 of the following 4. Okay. Now, basically the problems are actually worded the same as what you're getting on the test. It's just the amounts of stuff is what has changed. So Owen's making lemonade from concentrate. He needs 5 times the amount of water as he does of the lemonade concentrate. How many quarts of water and concentrate are needed to make 180 quarts of lemonade? So I know right off the bat, this 180 is different than anybody's got on a test. Okay. Well, assuming that there's no chemical reaction taking place, that tells us then that if W is the number of quarts of water and C is the number of quarts of the lemonade concentrate, W plus C is going to be equal to 180. And then we also know that we need 5 times the amount of concentrate for the water. So, oddly enough, I did this a long way because we already have one and solved for the other. I should have just plugged in the 5C up here for W and gotten 6C is equal to 180, but I did it the long way. I solved the top one for W and got W is equal to 180 minus C. So then I plugged that in for W in the second equation. And we get 180 minus C is equal to 5 times C. Add C to both sides, and we get 180 is equal to 6C. Divide through by 6, and we get that C is equal to 30. So we plug that up here in the first equation. W is 180 minus 30, or 150. So Owen needs 150 quarts of water and 30 quarts of concentrate in order to make 180 quarts of the lemonade. This next one is, the first one was a mixture type problem. This one is a work type problem where we want to find the speed that the boat was sailing. Well, it's a cruise boat. It's probably not going to be sailing per se, but as I understand it in nautical terms, that's how you say it. The motion of a craft is sailing, whether they're motoring or powered by an actual sail. Okay, so they're going to sail 80 miles down the Mississippi River in 5 hours and then come back at the same speed on the boat's speedometer in 6 hours. Find the speed of the current and the boat in still water. Now, if any of you have had physics or, well, I don't know, maybe just a fancy word problem in a math course. When you're on water, or if you're in an airplane flying with the wind or against the wind, if you're going with it, you combine the two rates to get the effectual rate of the boat with the current. Or if you've ever watched the 100-yard dash, for instance, in a track meet, when they talk about wind aided, as far as disqualifying somebody from setting a record, that's because the wind is helping to push them down the track. And so they're not really running as fast as they would be if there was absolutely no wind. Or if they were running into the wind, then the wind's going to resist them. So with the current, which is going downstream, we're going to have B plus C, where B is the speed of the boat in miles per hour and C is the current in miles per hour. And then coming upstream, that current's going to work against it, so we have B minus C. Now, it took 5 hours going downstream and 6 hours going up. Okay, so time times rate is equal to the distance from our the previous word problems that we've done with this. And in each case, it was 80 miles an hour. Let's get rid of these coefficients here, so we just have the B's and C's on the left. If we divide the first equation through by 5, 5 goes into 80 16 times. Okay, so that becomes B plus C is equal to 16. Unfortunately, I haven't figured out a way using my graphics pad to erase things, so that's why we've got some glommed up stuff here. If you divide 80 by 6, 80 over 6 is the same thing as 40 over 3 because they're both divisible by 2, so we might as well reduce it down. But 3 doesn't go into 40 an even number of times, so that's why I left it as 40/3. You'll notice we're going to tackle this by elimination this time, because we've already got C and a minus C. If we just add these two equations together and plug it in for a new second equation, then the C's will drop out. So B plus B is 2B, and then C minus C is 0, so we get just 2B times B on the left. 16 is the same thing as 48/3, so if we add 48/3 to 40/3, we get 88/3. Okay, so let's divide through by 2. And our second equation becomes B is equal to 44/3. If we divide 88/3 by 2, 2 goes into 88 44 times. So, solving then, we get that C is equal to 16 minus B but we know that B is 44 thirds. So again, 16 is 48 thirds. 48 thirds minus 44 thirds is 4 thirds. So the current is a little over 1 mile per hour. And, well, let's see. 3 goes into 44, roughly 14 2/3, almost. So the boat's going about 15 miles an hour, and the current's about 1 mile per hour. 14 2/3, I already worked it out. Okay, so probably the way it'll work out is that you'll get either the lemonade problem or the river current problem. I don't think anybody's going to get those for their 2 out of the 4, because these are both fairly difficult compared to the other ones. So I think you get one or the other of these, and then you get one of these next two that are easier. Okay, the next one is a geometric type problem. The difference of two supplementary angles is 28 degrees. Find the measures of the two angles. So we know that because they're supplementary, by definition, that means if you add the measures of the two angles up, we get 180 degrees. So that means A plus B is equal to 180. And then A minus B is 28, because the difference is 28 degrees. A is the larger of the two angles. Okay, again, because we've got this natural setup for eliminating one of the variables, I'm going to use the elimination method. And we're just adding the two equations and then plugging that in for our new second equation. That's how that elimination or linear transformation method works. So we still have A plus B is equal to 180, but when we add these two, we get 2A times A. B minus B is a 0, that drops out. And then 180 plus 28 is 208. We'll go ahead and divide through by 2 here, or multiply by 1/2. And that gives us that A is equal to 104. Then if we subtract, well, actually, I jumped ahead here. First, we're subtracting 2 times the first equation from the second. That way, 2A minus 2A times A is 0. 0 minus 2 times B is minus 2 times B. And then 208 minus 360 is equal to negative 152. So negative 2 times B is equal to negative 152, and we know that A is equal to 104. If we divide this top equation, both sides, by negative 2, we get just B on the left. Negative 2 goes into negative 152 76 times. And you'll notice that 76 and 104 does add up to the 180. Now, don't get wedded with this idea of 180, because probably on the test I'm going to use complementary angles, which we've already used in the past. And remember, that's where the two measures add up to 90 rather than 180. So the measures of the two angles then are 76 degrees and 104 degrees. All right. And then the fourth word problem is this one, another mixture problem. Okay, tickets for a baseball game are $59 for main level seats, or as us old-fashioned people would probably say, box seats, and $29 for terrace level seats, or the bleachers. A group of 12 friends went to the game and spent $498 for tickets. How many tickets of each type were purchased? In other words, They may be friends, but some of them have more money than the other ones, and so they didn't all sit together. Well, we know that they bought 12 tickets all together, so if M's the number of main level tickets and T is a number of terrace level tickets, we get M plus T is equal to 12. We also know, using our mixture formula for values, that if $59 times the number of main level tickets plus $29 times the number of terrace level tickets, has to add up to $498. So this is doing it by substitution, and really when we first did this type of problem, we were actually using the substitution method. We just didn't write everything down a whole bunch of times. If we solve this first equation for M in terms of T, we get that M is equal to 12 minus T. Then we substitute this 12 minus T in for M in the second equation. We get 59 times the quantity 12 minus T plus 29 times T is equal to 498. If we multiply, we distribute this 59 over the 12 minus T, we get 708 minus 59T plus 29T is equal to 498. 708, and if we add the negative 59T and the positive 29T together, we get negative 30T. So I'm going to add 30T to both sides to zero this out. So it's over here on the right now. And then we're going to subtract 498 from both sides to zero it out on the right. And we get then 210 is equal to 30T. Or that T is equal to 7, which I got written here. So now we take this 7 back, plug it in for T, we get that M is equal to 12 minus 7, or 5. Obviously it works for if we add these two up, we get to 12. Let's see what happens when we multiply it by the dollar values. Do we end up with the right number? Well, 59 times 5 is 295, and 29 times 7 is 203, and sure enough, you add those together, we get the 498. So they purchased 5 main level tickets and 7 terrace level tickets. So once again, you'll be getting, probably, I would say, either one of the lemonade or the river current problem, and one of the geometric problem and this mixture problem with tickets. Okay, then, as I promised, you'll get you actually have to find the solutions this time for 2 out of 3 systems of equations. And I can't necessarily promise that one of the ones you have here, whatever was left out of the first 2, is going to be one of the ones that you get for this one. But you only have to do 2 out of the 3. So let's look at this first example. Y is equal to minus x over 2, and x plus 2y is equal to 4. If we plug in the minus x over 2 into the second equation for y, we get 2 times minus x over 2 is just minus x. X minus x is 0, but that has to be equal to 4. There's no values. That's a contradiction. There's nothing we can put in for x and y that's going to make that a true statement. So there is no solution, which is the answer. And that is one of the possibilities that you're going to have for one of your choices out of the 4. So if you start working it out and you end up with a contradiction and nothing can make it true, then there's no solution. You've got two parallel lines that are independent. Okay, let's look at this second problem. System is 3x plus y is equal to negative 2, and 2 times x minus y is equal to 7. Let's just add the two together and plug it in for our new second equation. 3 plus 2 gives us 5 times x. 1 minus 1, that's 0. And then negative 2 plus 7 is 5. So our new second equation becomes 5x is equal to 5, or x is 1. So I elected just to go ahead and plug that in. 3 times 1 will give us a 3, plus y is negative 2. Subtract 3 from both sides, we end up then with y is equal to negative 5. So our answer is that xy is equal to the ordered pair 1, negative 5. Okay. So if it actually works out to a single answer, then you're going to get 1. Now, then the last one to look at here is 10x plus 5y is equal to 6, and then negative 30x minus 15y is equal to negative 8. Doing this by elimination, we take 3 times the first equation, add it to the second equation, and plug it in for our new second equation. That gives us 30x minus 30x is 0. 15y minus 15y, that's also 0, so we get a 0 on the left. And then 18 minus 18 is also 0. 0 equals 0. Well, that's always true. So basically when that happens, when you're solving it and you get a true statement with no variables in it, that means that you've got lines that coincide. And so you're going to have an infinite number of solutions. So we take one of the equations. In this case, we'll go ahead and use the first one and solve it for x in terms, or for y in terms of x. We get minus 10x plus 6, and then we divide through by 5. Negative 10 divided by 5 is negative 2. 6 divided by 5 is 1.2. So our ordered pair xy is going to be equal to the ordered pair w, and then minus 2w plus 1.2 for all real w. Okay, so no matter what value we plug in for w, that'll give us an xy that works and solves this system of equations. So again, you get 2 out of the 3 of those. All right. The next problem that all of you are going to have, but you're not going to need to draw a graph. I just went ahead and did it. Just to show you how it would be done. You have a system of inequalities. X minus y is greater than 2, and x plus y is less than negative 1. For this first one, our two intercepts are 0 minus 2 is our y-intercept, and 2, 0 is the x-intercept. So that's this line here. This is 0, negative 2. This is 2, 0. They're both strict inequalities, so that's why I've got the hollow dots and the dashed line. And it turns out that's our boundary. We need to decide which side of it has the works for this first equation, or inequality, pardon me. So the origin's here. If we plug in 0, 0, we get 0 is negative is greater than 2, which is not true. So this is not the side, so we shade below this line. That's the solution to the first inequality. For the second inequality, the boundary, the intercepts on our boundary are 0, -1, and -1, 0. So here we've got 0, -1. Here we've got -1, 0. Again, it's a strict inequality, so I use hollow dots and a dashed line. Let's look at the origin again to see which side of the line we want. Now, if we plug in 0 here, we get 0 plus 0, or 0 is less than -1. That, again, that's not true, so we don't want the values up here. We want the ones below this line. And it turns out that this point where they're going to intersect, but points on those lines are not part of either one, so that's why I've got a hollow dot here again. X is going to be at 1/2, and Y is -3/2. Now, you'll see here that we've got a double crosshatch area. Points in this region, that's the solution set. That's the intersection of the two areas defined by those inequalities. Now on the test, what will happen is you'll have this two sets of inequalities, and then I'll ask you which of the following 4 points lies in the solution set of that. You'll need to watch out for a couple of things, and basically all you're going to do is just plug in the coordinates and see if they come out with true statements. Some might work for one and not the other. Or, for instance, in the case of this strict inequality, you might have values like, is the point 2, -4, well, -2, 4. No, that doesn't work either. How about 0, -2? Okay, if we plug that in here, we get, that'll work here in the second one, of course. 0 plus a -2 is -2, which is less than -1. 0 minus a -2 is just 2. 2 is not greater than 2, so because it's not an inclusive, it's not greater than or equal to, that's not going to work because it's on one of the boundary lines. So that's the kind of thing you're going to look for. You're not going to actually probably draw the graph. You're just going to look at the points, the coordinates, and try plugging them in to each of the inequalities. If they make both of them true, then that's your answer. So that's how you'll be doing this type of problem, not doing a graph. We all seem to have too much trouble on the last test dealing with graphs, so I didn't want to do that again. Okay, then addition and subtraction of polynomials. So you'll have one of these two. You'll either have an addition or a subtraction. So basically you just combine the like terms. So p squared and 2 squared, they're both our p squared terms. So we're going to add those together and get 3 times p squared. There is no p to the first power term in the second one here, so we just end up with a minus 5p again. And then -15 plus 1 is -14. So again, here you're just combining like terms. In the subtraction problem, you'll need to worry about, subtracting a negative ends up being adding the positive. So again, we're adding like terms. 5b squared minus 3b squared. So 5 minus 3 will give us 2b squared. Minus 4b minus a negative 4b. Minus a negative is the same thing as adding a positive. So minus 4b plus b is a negative 3b, so we end up with minus 3b. And then minus 1 minus 2, that ends up being a negative 3. So that's a fairly easy, those are fairly easy. You'll get one of those. Okay. And here you're going to actually each get one of each, though not these particular problems. So we're dealing with products and exponents raising to a power. So a product raised to a power is each individual factor raised to that power. So 3x cubed to the 5th power becomes 3 to the 5th power times x cubed to the 5th power times, and we'll get 2 to the 4th power times x cubed to the 4th power. 3 to the 5th power is 243. X cubed to the 5th power, we multiply the two exponents and we get x to the 15th. Okay. 2 to the 4th is 16. And then x cubed to the 4th, we again multiply the exponents and we get x to the 12th. 243 times 16 is 3,888. And then x to the 15th times x to the 12th, we just add the exponents together and we get x to the 27th. Okay, so again, that's just applying your rules about products raised to a power, or a number raised to a power and then raised to another power. And the other one involves division. Now there's a couple of different ways to handle this. You can do canceling out of each pair first and then multiply stuff together. I decided to show it to you this way. Multiply your constant terms here. 6 times 5 is 30. A cubed times a to the 1st power is a to the 4th. And b to the 5th times b to the 4th is b to the 9th. Then on the bottom, the 15 is the only constant term there. So we have 15 times a cubed times a squared is a to the 5th. And b times b is b squared. Now it says simplify here. That means you're not going to bring everything up into the numerator if it's going to end up with a negative exponent. So since the 5 here is greater than the 4, a to the 4th will cancel with the a to the 5th, leaving an a, but it stays in the denominator. Okay. 15 goes into 30 twice, so we end up with a 2 in the denominator. And then b to the 9th divided by b squared, you subtract. 9 minus 2 is 7, so we end up with a b to the 7th. So this is 2 times b to the 7th divided by a. Okay. Now, I apologize for the sloppiness of this, but it does work out. Let's see. I guess I do have all 4 of them on there. Okay, you're going to get 2 out of these 4. Here we're multiplying a binomial times a trinomial, and I'm showing you that it works kind of like multiplication of integers. You have n and 3n squared plus n minus 7, and you're going to multiply it by n minus 4. So first you're going to multiply everything by 4. So negative 4 times negative 7 is positive 28. Minus 4 times the positive n is negative 4n. And then negative 4 times 3n squared gives you negative 12n squared. Then, just like in integer multiplication, you move over a column under the n and multiply everything through by n. So n times minus 7 is minus 7n. N times n is plus n squared. And then n times 3n squared is 3n cubed. So we'll have 3n cubed minus 12n squared plus n squared gives us minus 11n squared. Oh darn. I must have thought that was a plus 4n squared. Hold on just a second here. We can fix that. Sort of. This is minus 4 minus 7. So that's actually minus 11n and then plus 28. I just thought the verticalness of it might make it easy. You could also just go ahead and have n minus 4 times 3n squared plus n minus 4 times n minus 4 times 7, and then go backwards and have 3n squared times n minus 4 times 3n squared, and whatever. I just thought this might be easier, so I thought I'd show it to you this way. My apologies for not cleaning my glasses before I went ahead and finished this. Okay, so that's just a binomial times a trinomial. Okay, then we get into our special products type rules. A sum squared. So we have b plus 17 squared. That's the first term squared, or b squared, plus 2 times the product of these, so plus 2 times b times 17, plus the last term squared, so that would be 17 squared. So we have b squared. 2 times 17 is 34, so we end up with plus 34b as our middle term. And then 17 squared is 289. So the final answer here is b squared plus 34b plus 289. Likewise, we have a difference of squares, which is pretty much the same thing. The first term squared minus, in this case, 2 times the product of the first and last term, and then plus the last term squared. So 2d squared is equal to 4d squared, because it's 2 squared or 4 times d squared, minus 2d times 4 is 8d, and then 4 squared is 16. So when we completely multiply it out, and this is a little more complicated because we've got a coefficient on our variable term here, we get 4d squared. Negative 2 times 8 gives us the negative 16 times d, and then plus 16. Okay, that's the difference of squares. And then finally, the product of conjugates. Remember, a conjugate is where one term is, it's the first and last term is the same, but in one case you're subtracting, the other case you're adding. So this is going to be the first term squared, or x squared, minus the last term squared, or 3 squared. So we get x squared minus 9. And you could do this with the regular FOIL formula, and you get x squared minus 3x plus 3x minus 9, and then the 3x and the minus 3x zero out. So you can just do it the FOIL way, or if you got room in your head to memorize this formula too, it'll also work. All right, then also we have two division problems that work like integer divisions, like long division with integer numbers, and you can have a remainder. So we want to take v squared minus 8v plus 18 and divide it by v minus 8. Okay, what do we multiply v by to get v squared? Well, the answer is the v. So v times v gives us a v squared here, and then negative 8 times v gives us a minus 8v. When we subtract this from our above it, just like we would do in division, we come up with a partial dividend, we subtract it from the actual dividend. V squared minus v squared is 0. Negative 8v minus negative 8v, that's 0. And we bring down our next term, 18. And we're done. That's the remainder, because the degree of this is 0, the degree of this is 1, so we can't divide this into that. So two possible answers to this. You might see either one on the test. V is the part that we got up here for the quotient, and then comma r, the remainder, is equal to 18. Or you could write this as v plus 18 over v minus 8. Of course, it may very well be you'll luck out and get an actual factor. Now, the second one over here is mainly to show you that if you're missing a power of your variable, you need to put in the plus 0 times whatever that power is, so that you'll have something to subtract it from. Otherwise, it won't work. So we multiply u by u to get u squared. So we get u squared. We're always trying to get the first term to zero out, or subtract out. If it happens anyplace else, that's just, coincidence, a lucky coincidence, I guess. And then u times a negative 2 gives us minus 2u. So u squared minus u squared is 0. 0u minus a negative 2u is a positive 2u. And then we bring down the next term, minus 64. Okay. Now, to get u to be 2u, we multiply by plus 2. So 2 times u is 2u, Negative 2 times 2 is negative 4. 2u minus 2u is 0. Minus 64 minus a negative 4. That becomes negative 64 plus a positive 4, or just negative 60. So either the answer is u plus 2 with a remainder of negative 60, or u plus 2 minus 60 over u minus 2. Yeah. Again, with any luck, you know, things will work out and you don't have that remainder term to worry about. Okay, now, two problems having to do with scientific notation. One of them where the number is bigger than 1, one where it's between 1 and 0. And you'll get one of the two. If you get the one greater than for this, you'll end up with the next one where you're converting back to decimal notation. You'll have the number between 1 and 0, and vice versa. Okay, so remember we count the number of times. 1, 2, 3, 4, 5, 6, 7. We're going to move the decimal point over 7 times, and we end up with 5.08 times, and because we move 7 times, it's 10 to the 7th power. For the number between 0 and 1, such as we have here, we're moving the decimal point 1, 2, 3 times. So we end up with 3.5 times 10 then to the negative third. If you're moving the decimal place to the right, it's a negative exponent. When you're moving it to the left to change it to scientific notation, it's a positive exponent. Works out pretty much the opposite way when you're going from scientific notation to decimal notation. Okay, and like I said, you'll get one of these two. In this case, we start with 1.9 times 10 to the minus 4th. So we move back 4 spaces, 1, 2, 3, 4. We have to fill in with 3 zeros. So we end up with 0.00019. The 1 here took up one of our 4 places that we had to move to the left. Okay. And then 5.3 times 10 to the third. Okay, we move the decimal point over 1, 2, 3. The 3 takes up one of the 3 decimal places, so we only have to add 2 zeros. And we end up with 5,300. Okay, that's the 25 questions, out of which you will get 15 to do. That took about 40 minutes to go through. Again, if you have any questions, make a note of it and send me an email in Canvas. I'll probably end up getting it in my regular office email too, for some reason or another. What we did last Tuesday, or just yesterday, ended up all of your Canvas emails came to me as regular emails as well. But that's not important. Good luck on the test, and this is usually the hardest test out of the whole semester. The next one is the easiest. So we will look forward to grading these on next Tuesday, and I will be posting both a .odt version and a .docx version since some of you seem to have trouble opening the open source version of it, that .docx should work with whatever Windows is using for Word anymore. And good night.